Okay, so I'm going to be showing nomenclature. So for the first to nomenclature, I'm going to be showing you how to name ionic compounds. So as for the rules, the first rule is to name the cation or the metal. So we're going to name the cation, and then second, we're going to name the anion, which is the nonmetal. And we're going to write the first syllable replacing it with IDE. So example here, oxygen would be oxide, and then nitrogen would be nitride. So to show you my examples, I'm going to be showing you the PDF of my examples to make it easy. So AlF3. So the first step is going to be identifying the cation, which in this case happens to be aluminum, and then our anion, which happens to be fluorine. So for our second step, for the anion, we have to add the IDE at the end. So fluorine would then turn into fluoride. So then it would be aluminum fluoride. For our second example, we have potassium and we have nitrate. So, or NO2. So KNO2. So K would be potassium, and then NO2 would be nitrite, because nitrite happens to be one of our polyatomic ions. So right here, NO2 minus, NO2, and has a -1 charge. So I just put the charges, the polyatomic ion. So it would be potassium nitrate. So before we get into the rest of the examples for naming, I'm going to go over quickly about variable charge metals. So the only difference between processes with variable charge metals is you have to pay attention to the Roman numerals that are in the parentheses. So it's the same step. You're just adding a step to the process. So you have to first name the cation, and then the Roman numeral that indicates the charge on the metal in parentheses, and then you have to name the anion. So the reason that we have variable charge metals is because sometimes the anion would have a bigger charge or a smaller charge, so it changes. Therefore, that would change the cation to have a bigger charge or a smaller charge depending on the anion. So for example, here we have copper, and then Cu is copper, and then Cl would be chlorine. So we're adding chlorine would turn into chloride, and we have copper, so copper 1 chloride. So for my fourth example, we have Fe, which is iron, and then once again NO3, which is nitrate. So nitrate has a -1 charge, it's a polyatomic ion. So since it's in parentheses and it has a 3 on the outside, that means that it's signifying that NO3 has 3 nitrates. So then that would mean if it was 3 times 1, it would be 3 charged nitrate. So then that would mean that iron would need 3 irons in order to balance out the compound. So then that would mean that iron, parentheses 3 to signify that it has a bigger charge, and then nitrate. So for my last example, we have Pb, parentheses SO4, and then 2 on the outside. So SO4 is a polyatomic ion sulfate, and it has a -2 charge. So then that would mean if it has 2 on the outside, there would be 2 times 2. So it would have a total charge of 4. So then that would mean that lead would also need a 4 charge to balance out the compound. So then that would mean that lead, parentheses 4, and then sulfate. So that's for my naming. And then to show you how to write the formula of a given name of a compound, so it would be pretty much the reverse. So for example, here we have calcium nitrate. So calcium is Ca. So calcium has a 2+ charge. So if you look here, I have a trends for my ionic charge. Calcium has a 2+ charge right here. So if it has a 2+ charge and nitrate has a nitrate, once again, polyatomic ion, so NO3 minus, it has a -1 charge. So if this has a 2+ charge and this has a -1 charge, that means that you have to add 1 to the nitrate to balance it out. So it would look like something like this. So we have calcium, parenthesis, nitrate in the parenthesis, and then a 2 on the outside to signify we're adding another one or multiplying it by 2 to balance it out. So it would be calcium, parenthesis, nitrate, and then 2. For second example, we have sodium carbonate. So sodium is Na, and sodium has a +1 charge, and carbonate has a 2- charge. So it'd be the opposite on this one as opposed to this one. We're adding a sodium in order to balance out carbonate. So we would be Na2 because we added one, and then CO3, it just comes straight down. As for iron 2 chloride, so iron is going to come down Fe, and then chloride, it has a 2 right here. So chlorine usually has a -1 charge, but since there's 2 right here, that means that it's adding another chlorine, so it's going to have 2 charges right here. So since this has 2, and then there's right here it says 2 as a Roman numeral, sorry, Fe is going to have a 2+ charge, and this has a 2 charge too. So these would come straight down, FeCl2. So for fourth example, we have iron 3 nitrate. So Fe has a 3+ charge. That's what this Roman numeral is telling us. And then nitrate comes down and has a -1 charge. So then that would mean that if we would need 3 nitrates to balance out the 3 irons. So Fe parenthesis nitrate and then 3 on the outside. As for copper 1 phosphate, we have 1 copper and then phosphate 4 is equal to -3 charge. So since there's copper is going to come straight down, and then we're going to have to add 3 to the copper in order to equal phosphate -3. So this would be copper 3 and then PO4. So I hope this helps explain nomenclature, and thank you.